Hello, Geometry. This is section 3 of chapter 9. Our last little start with right triangles. After this, we're going to actually get into a little trigonometry and learn how to use those sine, cosine, and tangent buttons. That's the sin, cos, and tan button on your calculator. But for right now, we have similar right triangles. We're going to have a right triangle. We're going to be right a lot today. And our main question here is, are the altitudes. Remember, the altitudes are the height of the triangle. It has to make a 90-degree angle with a side. Okay, so the height, that's the altitude. And geometric means of right triangles related. So the terms there, geometric mean. That is going to be a new one here. You are used to what is referred to as the arithmetic mean, or the arithmetic mean. So the arithmetic mean is when you take x plus y and divide by 2. So if I want the arithmetic mean of 3 and 5, I would take 3 plus 5, divide by 2, and I would say the arithmetic mean is 4. 3 plus 5 is 8, divide by 2, that would be 4. What the geometric mean is going to be, it is the square root of x times y. The square root of x times y. So that would be the square root of 3 times 5. So that would be the square root of 15. That's referred to as the geometric mean. So we have heights of right triangles. So they've drawn a right triangle here. They have drawn the altitude of that. So if I flip it around here, there we go. There's our base. There's our hypotenuse. And we have an altitude because that's a 90-degree angle. It has to come from a right triangle. Okay. So what we're going to see is when we do that, this diagram here, hang on. So when I have a right triangle, kind of blurry on you, let's slide this under. Oop. Ruining my surprise there. Oh well, yeah. Okay, so when we have a right triangle, there's my right angle right up there. There are 3 triangles that are formed. Okay, we have my blue one, we have my red one, and then we have this white one right here. So that's my altitude of the right triangle. All 3 of these triangles are going to be similar to each other. That means they each have corresponding angles that are congruent. They each have sides that are proportional. Okay, so the blue triangle, I can take it. You can't really tell too well. I should have drawn it a little bit better. But this is my short side. So I can lay that over there if I flip it over, and that would be similar to my big triangle. Same thing goes for my red triangle. Let me slide it underneath. They are all similar to each other. If I match up the 90-degree angles, I'm going to have 3 sets of parallel lines here. Because these 3 angles are the same on the left, these 3 angles are the same on the right. All these hypotenuses would be parallel if I could take the triangles and mix them up like that. Okay? So there's some certain properties with these right triangles that come about because they are all similar. And it has to be a right triangle and an altitude drawn with the right triangle. Okay, that's the last lesson. Don't need that page. So the geometric mean, we've talked about that already. That is the square root of the product of 2 numbers. The square root of the product of 2 numbers. So for our geometric mean, we had 5 and 6. The geometric mean would equal the square root of 30. Okay, if we can't simplify that, we would if we could. You can get the decimal answer, about 5.47. Right. So those answers can be provided either as a square root or as a decimal, depending on what they want there. Okay, so right triangle similarity theorem. That's what we're talking about here. Here's your right triangle with an altitude drawn. It creates 2 other triangles. Okay, you are going to have 3 similar triangles from this. There are 3 similar triangles. we're going to write them out a little bit differently. Let's look at the corresponding parts back on this. I'm going to start with my red triangle. Okay, so let's write triangle ABD. So this is my left side. Triangle ABD is similar to, let's do the big triangle next. So what happens, I want A to B to D. We're writing similarity statements. We're going to have to do this later. A to B to D. Notice I went to the hypotenuse, and then I went down the shorter leg, and then the longer leg. So if I'm going to match this up with my big triangle, I have to flip it over, and that A to B corresponds to A to C. So that's going to correspond to ACD. ACD. So I want you to notice on this first triangle, I'm going to name my first triangle going up the side, ABD. My big triangle starts back at A and goes along the bottom, ACB. So A, say it with me, ABD is similar to ACB. Now the final one is this one right here. Now notice this is kind of a rotation. If I take my blue triangle and I rotate it, it matches up with my red triangle. So if I rotate that the other way, I'm starting with angle A. So angle A, when I get to my blue triangle, actually corresponds with angle B up here. So I want ABD. So I have to go BCD. BCD. And that's the right side. So ABD is similar to ACD, which is similar to BCD. Hopefully you see those moving around. You can see those parts. Okay, let's practice that with some other letters here. So over here I'm going to draw a diagram that we have. Make that a right angle. It has to be a right angle up there, and that has to form a right angle down there. Okay. Let's go MNOP. MNOP. So write the three triangles that are similar here. So I'm going to start with my left side. I'm going to start just right here on the left corner, and I'm going to name this left triangle. So MNP. So MNP. So that's the left side. Now the big, we're going to go down here. So I want M and P. Now I'm going to go this way. The big triangle, MON. MON. And then the right side, we need to rotate up. Okay, so M matches up with N, and then we're going to go down here because we went to the hypotenuse first. Hypotenuse first for the little triangle, then the short side. So that is similar to triangle NOP. Nope. Okay, we'll practice that some more later on. Okay, here's the geometric mean. We're already talking about that. A and B is the positive number x that satisfies A over x equals x over B. If you double pickle this, what you get is AB equals x squared, so x equals the square root of AB, which is what we've already been talking about. Geometric mean, square root of the product of two numbers. Okay. So we're going to have, they didn't practice any of that. Okay. So before we go on to these theorems here on page 255. Really? Did not put, I didn't even catch that either, huh? Here we go. These are some of your first problems you'll have to solve. They want you to find the x, find the altitude, and let's say I'm going to make up some numbers. This will be fun. 12, 8, and 17. 12, 8, and 17. Okay, so we have A, B, C, D. So let's write our similarity statements out now. We know triangle ABD is similar to triangle, okay, go the other way, start back to ACB, which is similar to triangle, rotate it up, BCD. So what we're looking for here is BD. Go back. This should be ABD. ABD here. ABD is similar to ACB. So here's a D. We're looking for BD, which you know shows up right here. So BD is let's look at our corresponding parts. It corresponds to CB. Okay, well CB is 8. So I have BD over CB. So that becomes BD over 8. What else do I know? Let's go back to this. BD, do I know AB and AC? You see that? Equals AB. You see how AB corresponds to AC? So AB is 12 over AC. So AB over AC has to equal each other. So BD over CB has to equal AB over AC. There's our formula. BD over CB has to equal AB over AC. So AB over AC is 12 over 17. So I get BD, the height, divided by 8 equals 12, this side over here, divided by 17. So when I multiply that 8 up there, or do the Z method, BD equals 8 times 12 divided by 17. Let's look at where these numbers come from. 8 times 12, you notice, is just 8 times 12. Divided by 17 is the bottom side. That's going to be the formula you want to use for this. So when you're looking for the height, and you know this total length, you're going to have problems where you don't know that total length. You're looking for the height, and you're looking for the total length. It's leg times leg divided by hypotenuse. Okay? So let's finish this up. This is 96 divided by 17. That's a fraction in lowest terms. Whoops. Which is about 5.65. 5.65. That would be your altitude. Okay? So let's write that back down over here. So altitude equals leg times leg divided by the hypotenuse. The three parts must be from the largest triangle. Must be from the largest triangle. Okay, that makes this pretty easy. Leg times leg divided by hypotenuse. So there, that has to be a right angle. That has to form a right angle. We're looking for the height there. Let's say this is 6. Let's make that 13, and let's make that 15. So if you're looking for x, you're going to take 6 leg times 13 leg divided by 15. Okay, you can get all into the formulas of it, but that's going to be what it is. 6 times 13 divided by 15, 26/5, that is 5.2. So x equals 5.2. Okay, leg times leg divided by hypotenuse. 6 times 13 divided by 15. And we're going to have those formulas here showing up the rest of this time. Geometric mean, the altitude theorem. So notice here, in a right triangle, the altitude from the right angle, what we have, divides the hypotenuse into two segments. The length of the altitude is the geometric mean of the lengths of the two segments of the hypotenuse. Okay, so let's start again with our triangle similarity. Triangle ACD is similar to triangle ABC, which is similar to triangle, rotate up, CBD. So they're asking again about CD. CD over, we're not using BC now, CD over BD. Okay, CD corresponds to BD. And that has to equal AD over CD. You see that CD show up again? So that has to equal AD from those two, over CD, corresponding parts. AD over CD. So when you double pickle or cross multiply, that goes up there, that goes up there, you get CD squared equals BD times AD. That's what they have here. CD squared equals AD times BD. So how that's going to just work there is if you have right angle, altitude, they're looking for that one. If this is 5 and this is 4, x squared equals 5 times 4. X is going to be the square root of 20, which if you simplify, that's 4 times 5, that's going to be 2 root 5. Okay, that is simplest form. Pair of 2's right there. So 2 root 5. If they want a decimal, you can put it as a decimal. Okay. You can sometimes be looking for this. Let's say that's 6, that's x, and that's 10. Well, you're going to set it up the same way. You know the two parts. That's the difference here. These, you know the two parts. In this question here, you didn't know the two parts. You knew the entire length and those two legs. Okay. So this altitude is dealing with the three sides of that triangle. This altitude is dealing with the side that's perpendicular with the two parts there. So the altitude squared, so 6 squared equals 10 times x. So 36 equals 10x. Divide by 10, you get x equals 3.6. Okay? So altitude squared equals the product of that. That is the geometric mean of the two parts there. So geometric mean, the leg theorem. Okay? So CB, let's talk through this. CB equals DB, its corresponding side right there, times AB, the entire side. So CB is the geometric mean of its closer part and its total length. The length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. So the hypotenuse is AB, and the segment of the hypotenuse that is adjacent to the leg you want. So if I'm looking for CB, this part of the hypotenuse is the part that is adjacent to it. So CB is going to be the square root of DB times AB. DB times AB. Likewise, AC, the other side, I'm going to take the hypotenuse times the part of the hypotenuse that is adjacent to the side I want. So AC is going to be the square root of AD times AB. So here's your formulas. You want to make sure to get this down to got a right angle there. Okay, so I got a right angle up there, got a right angle there. I want you to label these parts up here, X, Y, and Z. And I'm going to label these parts A and B. A and B. Okay. So here are our four formulas that we know. If you're looking for Y, Y can equal X times Z divided by A plus B, or Y can equal the square root of A times B. Okay, so this is from the first one, our similarity theorem. Leg times leg divided by hypotenuse, notice A plus B, or it can be the square root of A times B. If you're looking for X, this comes from this geometric mean leg theorem. Mean leg. It's a mean leg. Anyway, that is going to be the square root of the hypotenuse, A plus B, times its leg. So it's A times a plus b. A times a plus b. So it has to be entire part there. And if you're looking for z, that is going to be the square root of b times a plus b. So it's corresponding parts. So you can kind of use this to match up whatever you want with that. Okay, let's get to work here. So, exercise 1 and 2, identify the similar triangles. Okay, so we're going to start here on the left side. Okay, write your first triangle, go up first. I'm going to say triangle HJK. Up and then down. I'm doing that one first. HJK. That is similar to triangle. Now I'm going to go the other way and get the big one. HIJ. HIJ. So I got that one. Now I need to get the one on the right. I'm going to rotate up and start up here and then slide down that last one. So that is similar to triangle JIK. Okay, similar to triangle JIK. All right, you stop it, pause it, try number 2. Number 2, it may help if you kind of move this around like that if you want. So that's NMP, there's my first one. Triangle NMP, is that a P? Yeah, okay. It's similar to, now I'm going to go the other way, NOM, triangle NOM, which is similar to, rotate up, I'm going to start with M and slide down to home plate. Triangle MOP, the mop. Okay, so there are your 3 similar triangles. Okay, keep in mind, number 1, you need the answer to this, right triangle similarity, since we're talking about that. If the altitude is drawn to the hypotenuse of a right triangle, then the 2 triangles formed are similar to the original triangle and to each other. Okay, so question number 1, I think, is a vocab question, which is dealing with that right triangle similarity theorem. Find the geometric mean of the 2 numbers. You're just going to say the square root of 2 times 6. That's the square root of 12. That's 4 and 3. That's 2 and 2. So that's 2 root 3. Okay? If they want a decimal, you use your calculator. If they want exact numbers, you'd have to use 2 root 3. 5 and 45. So that's the square root multiplying 5 times 45. That's going to be the square root of 5 times 50 is 250. 225, I believe that to be 15. Yes, so that'd be 15. Go ahead and simplify that when you can. Okay, find the value of the variable. Okay, these are our formulas that we had going on here on the other side. So this is my altitude, and notice I have the 2 parts of the hypotenuse. So x is the geometric mean of these 2 numbers. So x is going to be the square root of 9 times 16, which is going to be the square root of 144, so x is going to be 12. So height there is 12. On y, you have to recognize what you have. We have this leg right up here. Here's our big hypotenuse. Y is going to be the geometric mean of 9, and the entire length, which is 11, 9 plus 2. Okay, so this is kind of like the A, this is the B in our formula. So, again, go check your formula. We're looking for x. X is the square root of A times A plus B. So 9 times 9 plus 2, so y equals the square root of 9 times 11. So y is the square root of 99. Okay, I think a lot of times they will want the decimal. 9.94. Not how long it is. If they want the exact answer, that's going to end up being 3 root 11. 3 root 11. 9 has 2 3's in it. Okay, let's get to some more variables here. Kind of a skinny one. Notice we have a 49, we have a side here. We know 7, and we know the total length. Okay, they want us to find the total length. So if 49 has to equal the square root of 7 times t, the close part times the total part, That means 49 squared, that's how you solve. To get the square root off, you square it, equals 7t. Okay, 49 squared is 2401. Equals 7t, divide by 7, divide by 7, and you get 343. So that total length there is 343 feet. Okay, 6. Again, we know 6 here. There's 3, and there's a plus 4. So 6 equals the square root of 3 times a plus 4. 3 times a plus 4. Okay, because 6 is, you don't need the total length there, it's just the geometric mean of the two parts. So square both sides, so 6 squared equals 3 times a plus 4. So 36 equals 3a plus 12 minus 12. 24 equals 3a, and then divide by 3, you get a equals 8. It would equal 8. So this side over here would be 12. That side's 12, that side's 3, that side's 6. Okay, keep in mind the practice that we did over here, when you know when you're looking for the altitude, we did those, and then also on these. Okay, quick reminder, when you have all three sides and you're looking for the altitude, you take leg times leg divided by 15, and that'll give you the altitude as well when you have those formulas. So that takes care of 9.3. Good work. Just a lot of these formulas, knowing when to apply them, how to apply them, that's kind of the tricky part with it. But after this, we're going to get into some trigonometry, some fun stuff with that, solving triangles, more application with that, into finding heights of objects and lengths of objects when you just know a side and an angle. That's what the trig is good for, is when you say, I have a right triangle, I know one side and I have an angle, let's find the other two sides. So keep up the good work. We'll see you in class.